Okay, guys, we're going to get into lesson 3 of unit 9. More area, and what we're going to talk about is composite figures. And a composite figure is just a mix of a bunch of different figures here. So let's go ahead and get rolling with this and take our time with it. A composite figure is made up of two or more shapes, right? We can find the area of a composite figure by adding or subtracting. Sometimes we're going to have to take away the area of each shape. Okay, so you could look at these different two-dimensional figures. We certainly could find the area of any of those, but we're going to kind of roll down to this next piece here. Okay, so now we have kind of looking at a house. We have a base, a height, and then this height kind of goes to the peak. And what we're going to do is cut this, okay? We're going to cut this into two figures, all right? And shape 1 is going to be right here, shape 1, and shape 2 is going to be this. So first off, shape 1 is a triangle, right? And shape 2 is looks to be a rectangle. And I'm just going to abbreviate that. All right, so the formula for a triangle is area is 1/2 the base times the height. So let's plug in. So now we have to bring this up. So it's 1/2 times 9. Now, if the whole thing is 12 and this is 8, 12 minus 8 will give us from here to here. And remember, that has to be a perpendicular height, which is 4. So when we look at that, we're going to get 9 times 4 is 36. Half of that is 18, and that's in feet square. The rectangle is a little bit different. It's, area is base times height, and then we have 8 times 9, which is 72 units square. And then the total area is when we add these two together, and we're going to end up with 90 feet square. And that was feet, I'm sorry. Okay, so let's take a look at this next one. It's a little bit different. Anyway, we're going to draw that across like that. Okay, and now shape 1 is a triangle, right? Okay, we're going to keep that triangle the same. And shape 2 is a rectangle. Okay, so shape 1, the formula is, again, 1/2 times the base times the height. And this is just base times height, isn't it? Let's plug in our values. 1/2 times the base of 15 times the height of 5, right? 15 times 5, and then half of that, right? So that's 37 and 5/10, and that's meters square. Base times height is 9 times 15 here. That's our rectangle, and that's 135 meters square. Okay, so then we're going to add these two together right now, and we get 172 and 5/10 meters square. So these are two separate composite figures, and we're just combining them, or we're adding them. Okay. All right, let's flip to the other side. Let me adjust my camera here and see if we're in good shape there, which we are. Okay, and let's get rolling. So a composite figure also includes overlap. Okay, shapes. Describe the process for finding the area of the shaded region. Well, what I would do is find the area of the big rectangle, find the area of the parallelogram, and then I would subtract the two, right? And I'm not going to write all that out, but that's what you're going to do. Area of 1, area of 2, and then we're going to find the difference, right? And let's go ahead down to this trapezoid with this rectangle in it. Okay. Now, we have to, and if you need to, you can refer back to your formula sheet. But the first thing I'm going to do is find the area of this rectangle right here. Okay, and the rectangle, I'm going to go ahead and write like that, is 5 times 7, which is 35 inches square. Whoops. Inches square. Okay. Then I kind of like draw a line. Now, The formula to find the area of a trapezoid is 1/2 base 1 plus base 2 times the height. Remember that? So it's 1/2 times parenthesis base 1 is 15, base 2 is 10, and the height is 8. And if you were to plug all of that in, we can do that here, 15 and 10, right? So if we just use our calculator, and actually we could just use the parentheses in it. So let me go ahead and show you that. So it's 1/2 times the quantity of 15 plus 10, close that, and then times 8, and we get 100, right? We're going to get 100. So we're close. That's 100 inches square. So now this is an overlap. So what we have to do is we have to subtract the two. And I'm going to come up here and do that. So it's 100 minus the 35. And that ends up being 65 inches square. Okay, so that's the area of just the shaded region. All right. Okay, so let's continue on with our patio. Okay, a patio is being landscaped with trees and shrubs. How many square feet of landscaping will be around the patio? Okay, so around the patio, how many square feet of landscaping will be around the patio? All right, so a patio landscaped with trees and shrubs. All right, so we want landscape here and landscape here. All right, so when I look at that, we're going to find the area of these two pieces. That's what I'm seeing here. A patio is being landscaped with trees and shrubs. How many square feet of landscaping will be around? So we have to be careful here, because if we find the area of this rectangle and then just add them, we're going to count that patio twice. So what we have to do is find the area of this, and then take one of these patios out. Okay, so what I would do here is I would take 14 times 8. Okay, and 8 fours are 32, carry the 3, 8, 9, 10, 11. That's 112. So that takes care of kind of figure A right there, right? And in figure B is, again, 8 times 14, so we'll call this B. And it's 8 times 14, and that's also 112, right? So that's the area. They're congruent. They're equal. Now, here's the piece, all right? What we have to do is add these two together. So we take 112 plus 112 and end up with 224. Okay. And then what we're going to do is we're going to find the area of one of these and take it out. Okay. And take it out. And actually, we're going to take two of these out because we have a double, I guess. It's the question's a little confusing. But anyway, from here to here, we need to figure out, well, if this is 3 and this is 8, that means this is 5. Okay, and we need to figure out what this is right here from here to here. Well, if this is 14 and this is 3, this has to be 11, right? So let's take this down and call that PC. 11 times 5 is 55, right? And that's 55. All right, now, the problem's going to be here, guys, is there's not just one of these, but there's two of these. So I'm going to double that and get to 110. Now, if you recall, I got this 224 by adding these two numbers. So I'm going to rewrite that. This is the area of both patios. And remember, when I found the area of both of these, all right, I've counted it twice. So I had to double that. And I'm going to subtract that away because I have that major overlap. And I end up with 114 feet square. And that was kind of a confusing question because I wasn't sure, what they wanted the area for, but they don't want anything in here. So we're taking this piece out. Okay. All right, let's keep going. We're going down to number 3. Let me check my camera here and make sure we're in good shape. This is composite figures. A composite figure is created by using a square and a triangle. What is the area of the figure? Okay, so I'll call this figure A and this figure B. No problem. Well, this is a square, so all sides are congruent. So figure A is 12 times 12, which is 144, right? Okay. Now, here's the next piece. They give us this dimension from here to here. And what we're going to do is we're going to find the base and the height of this on figure B. So figure B is going to look like this, okay? And we're going to call that, if that's a square, that's 12. I can transfer that over to 12. This is 12. And the whole thing is 21, okay? So, all right, what I'm going to do is subtract, and I'm going to end up getting 9. So this piece is 9. And remember, the base and the height have to be perpendicular to each other, times 9. And remember, I also want to multiply that at half. So it's base times height, or 1/2 the base times the height, okay? So we found the area of this. It was 144. Now we're going to find the area of this triangle, right? Well, there's an easy way to do this. I can take half of 12 and get 6, and 9 times 6 is 54 inches square. So now all I'm going to do is add these two together. So 144 plus the 54 is 198 inches square. And that's the area of this figure B. And this was the area of figure A, the square in the triangle. Okay. Okay, we have one more to take a look at here, and it says find the area of the shaded regions. So it looks like we have a square, and then 9 times 9. So the square is 9 times 9, which is 81. Okay, we'll label it at the end. The triangle is 1/2 times the base of 9, and the height is actually 9. So 81, half of 81, okay, is what? So we could just kind of punch that in and see, just to make sure. So we could say 0.5 times 81, and we end up with 40.5, right? So that's 40.5. And since we want to take that out, we're going to subtract those two. So let's just continue with this. 81 minus 40.5, and we end up with 40.5 again. So this is 40 5/10 meters square, and that's the area of this shaded region. So I hope that made sense, guys. Composite figures, we can have a lot of fun with this, and we will. All right, go ahead and head to the homework. Thanks.